discuss what's called searching, sorting, and algorithm analysis. These are the topics that we'll go over: the search algorithm, searching an array of objects, introduction to sorting algorithm, sorting an array of objects, sorting and searching vectors, and then intro to analysis file algorithm. So search is to locate a specific item in a list, array, or a vector of information. So two algorithms. Methods considered here are linear search, also known as sequential search, and also a binary search. So within this unit, I attached two videos that you can look at. So the linear search, the way it works is set found to false, and then set a position to -1, and then set index to 0, and then you have the while loop going through it. This is the longest search. Basically, when it's searching for something, it has to go through every item that is in the list. So the linear search, you use, say, array numList contains 17, 23, 5, 11, 2, 29, and 3. Then searching for the value 11, linear search examines 17, then 23, then 5, then 11, and so forth. Searching for the value 7, linear search examines all the values that are in there. So it basically checks every item in there when it's searching for an item. So the benefit is easy algorithm to understand and to implement. Elements in an array can be in any order. The disadvantage is inefficient. It's slow for array of n elements. It examines n2 elements on average for a value that is found in the array, n elements for a value that is not in the array. So for example, if I'm looking for Tavish and I have to start from here, so I have to say, are you Tavish? No, are you Tavish? 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 Until, let's say, if Tavish was the last person that I'm checking, then he would be the last one. So it's time consuming when you're using this type of search. The binary search, on the other hand, it's different. So it divides sorted array into 3 sections. So the word here is a sorted array. If the array is not sorted, it won't use. So it's not the best option to do it. So the first thing you have to do is you have to make sure that for the binary search that it's actually sorted. So you have the middle element, you have elements on one side of the middle element, then elements on the other side of the middle element. So if the middle element is the correct value, done. Otherwise, go to step 1 using only the half of the array that may contain the correct value. Continue step 1 and 2 until either of the value is found or there are no elements to examine. So it basically divides it into 2 parts, basically the middle section. So here you have array numList 2 contains 2, 3, 5, 11, 17, and 23, 29. Looking at the previous array, so this had to be arranged first, sorted. Okay. So searching for the value 11, binary search examines 11 and stops. So if it goes to the middle, is this 11? If the answer is yes, then it would stop. Searching for the value, binary search examines 11, then 3, then 5, and stops. Okay. So the benefit is much more efficient than the linear search. So for an array of n elements, it performs at most log 2n comparison. The disadvantage is that it requires that an array elements to be sorted. If it's not sorted, it won't work. Search algorithms are not limited to arrays of integers. So when searching an array of objects or structures, the value being searched for is a member of an object or structure. So not the entire object or structure. So remember, in an object structure, key field uses key field, so value used in search is search key. So sort, arrange values into an order, and alphabetical, ascending, smallest to largest numeric, descending, largest to smallest numeric. So 2 algorithms considered here are the bubble sort, and then you also have what's called a selection sort. So compare first 2 elements and exchange them if they are out of order. This is for the bubble sort. Move down 1 element and compare second and third elements. Exchange if necessary. Continue until the end of the array. So pass through the array again, repeating the process and exchanges as necessary. So repeat until a pass is made with no exchanges. So an example of the bubble sort. So we first compare the values 17 and 23. So this would be the incorrect order, so no change. This is in a correct order, so you don't have to change anything. Now finally you would arrange the value 23 and 5 now not in correct order, so you have to switch them, right? So you have to, so again, if you compare this 23 and 5, so this is not in correct order. So you don't have to, you have to make a change, but you have to finally arrange this two as well. So this is, there is no change here, then this you have to rearrange it. So after first pass, an array num list contains 17, 5, 11, and 23. So originally it was 17 and 23, and then you had 5 and 11. There was no change on this side, but there was no change on this side. Now here you had to switch the 23 and the 5, so that's why you have 5 moved. So after the second pass, array num list contains, so now you have to rearrange the last one. So this is, there's no change here, but here you have to switch. So you have 17 and 23. Okay. So the benefits easy to understand and to implement. The disadvantage is inefficient, makes it slow for a large array. If something's short, it's fine, but you have to keep comparing if it was a large data. For the selection sort, so you locate the smallest element in an array and exchange it with an element in position 0. You locate the next smallest element in an array and exchange it with element in position 1. So you continue until all elements are in order. So here's the array. You have 11, 2, 29, and 3. The smallest element is 2, so exchange that with the first array. And then you have 2, 11, 29, and 3. So you look at the next smallest element is 3, then you exchange 3 with the second array, and so forth. The next smallest element is 11, so exchange it with the third array, and so forth. So it's kind of step by step. So benefit is more efficient than bubble sort due to fewer exchanges. The disadvantage is it's considered harder than bubble sort to understand and implement. As with searching, arrays to be sorted can contain objects or a structure. The key field determines how the structure or objects will be ordered. So elements when exchanging of the contents of array elements, entire structure of objects must be exchanged, not just the key fields in the structure of objects. Right? So for this, I loaded a couple examples here that you can look at. So here you have a couple of video, one for the binary search and another one for the search, linear search. And you can quickly look at these videos and move it as you like. And it will go through it and run it, basically. You can take the sample and basically test it as well. Of course, you can use the examples that come with the text as well. Okay. So kind of like the presentation we're going through. All right. And that would be it.